Section 9.3, the ellipse. So, recall we're dealing with conic sections, so that is if you take a plane and you intersect the cone, not perpendicular to the center axis, but off a little bit, you'll get what's called an ellipse. An ellipse is basically an oval, but technically it is the set of all points in a plane, the sum of whose distances from two fixed points, the foci, is constant. And so let's look at what these points are going to be called and where they are located on our ellipse. So this is the form of the ellipse we're going to deal with. We may deal with it long ways on the x-axis or long ways on the y-axis, and specifically major axis is going to indicate the long portion. So the center of an ellipse is the midpoint of the segment between the foci. Okay, so in this situation the center is at the origin. The major axis of an ellipse is going to always be longer. And so really all you have to do is, if you look at the graph, the wider or taller part, whichever one's bigger, if it's wider, then the major axis is horizontal. If it's taller, then it's going to be the major axis is on the vertical. One thing to remember, and that's going to be how we find a relationship between A, B, and C in these formulas we're about to deal with. Okay, so every time I mean that A is going to be the distance between the focus and the covertex, and B is the distance between the center and the covertex, and C is the distance between the center and the focus. Additionally, it's useful to know that the distance between the center and the vertex is also A. But what primarily matters in this formula is that A is always bigger than B. Alright, so standard equations of a horizontal ellipse. When I say horizontal, it's just going to be wider than it is tall. So specifically, it's still true that c squared is equal to a squared minus b squared, and the center is going to be hk. Then what do we get? Alright, so horizontal is our major axis. Okay, so specifically, A being bigger is going to be under the x stuff. Notice that the standard equation of an ellipse is it's equal to 1, and so if there's any constants over there, you have to divide by them to get them over on the left-hand side. But we will see this. So then where are our vertices? Well, our vertices are going to be h minus a, k, and h plus a, k. Recognize that what you're doing is you're taking the center and you're going to the left a distance of a, and you're going right the distance of a. Then the co-vertices, in this situation they're going to be vertical because that's going to be the shorter edge, and so the co-vertices are going to be a distance of b above and below the center. Then the length of the axes, the major axis is 2 times a, and the minor axis length is 2 times b. Then the foci can be found by finding c, which is c squared is equal to a squared minus b squared, and that's going to be a little bit to the left of the center, a distance of c, a little bit to the right of the center, a distance of c. Then, dealing with our major axis being vertical, what's going to happen is the larger number is going to be under the y stuff. So remember that a is always bigger than b, and so here we have x minus h quantity squared over b squared plus y minus k quantity squared over a squared. The a being larger tells us that the major axis is vertical. Well then, all the rest of the information is about the same, it just swaps from x's to y's. And so the vertices are then going to be above a distance of a and below a distance of a from the center. The covertices are going to be left a distance of b and right a distance of b from the center. And then the length of the axes, the major is still 2a and the minor is still 2b. Major and minor axis length will always be the same. And then the foci here, because we're talking about the major axis being vertical, you're just going to go up a distance of c and down a distance of c, where of course you find c from c squared equals a squared minus b squared. Alright, so let's do this. Find the standard equation of the ellipse with major axis endpoints negative 5, 0, 5, 0, and foci negative 3, 0, 3, 0. Alright, so I'm going to sketch these. And so first off, negative 5, 0, and 5, 0, negative 5, 0, and 5, 0, these are vertices, okay? Alright, well then we're also told the foci. Well, but the foci I'm going to write down as a different color because they're just reference points. And so negative 3, 0, 3, 0. Alright, so those are the foci. At this point, we need to find the standard equation of the ellipse with the major axis endpoints being negative 5, 0, and 5, 0. Recognize that these being on the x-axis, we know that we're going to use the standard equation of a horizontal ellipse. And so our ellipse is then going to be of the form x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. Alright, a few more things that we already automatically know. Recognize that if you find the midpoint between negative 5, 0 and 5, 0, that's the origin, so we know that our center is specifically the origin 0, 0. Halfway point between the foci, halfway point between the endpoints of the major axis. And really there's only three other things we need to find: A, B, and C. Well, A, recognize, is half the length of the major axis. And so since the major axis goes from negative 5, 0 to 5, 0, that's a length of 10. A is going to be 10 divided by 2, or 5. Okay? Now we don't know B, but I claim we know what C is. C is the distance from the center to the foci. But since the foci are at 3 and negative 3 on the x-axis, then I know that C is specifically going to be just 3. Alright? So I've got A and then I've got C. Well, then I just need to recall that C squared is equal to A squared minus B squared, and then I can use this to find my B. So 3 squared is equal to 5 squared minus B squared. That's going to be 9 is equal to 25 minus B squared. 9 minus 25 minus 25. That gives me negative 16 is equal to negative B squared. Divide by negative 1, divide by negative 1. I get that 16 is equal to B squared. Take the square root of both sides. And so I get that 4 is equal to B. And so now I know that B is equal to 4. Now I claim that we can finish this out. That's going to be x minus 0, quantity squared, over A squared, that's 5 squared, plus y squared over B squared is 4 squared, is all equal to 1. If you wanted to square those values to type that in as x squared over 25 plus y squared over 16, that would be perfectly fine. At this point, I claim that we can finish graphing this because we know that the co-vertices are going to be a distance of 4 above the center and a distance of 4 below the center. And so then I claim that my ellipse looks about like that. Okay, so now we have the ellipse 9x squared plus 4y squared is equal to 36. We want to find the center, the vertices, and the foci, and then we want to draw the graph. So, step 1, we've got to get it in its nice format, which means that we need this equal to 1. And so what we're going to do is we're going to divide by 36 all the way across. And so, dividing by 36, we get 9x squared over 36 plus 4y squared over 36 is equal to 1. Okay, I do need to simplify these fractions. But 9/36 is 1/4, and so this is going to be x squared over 4 plus 4 divided by 36 gives us y squared over 9 is equal to 1. And then at this point, if we want to get everything in the perfect format, I need to rewrite the denominators as something squared. And so this is going to be x squared over 2 squared plus y squared over 3 squared is equal to 1. Okay, so we can answer the center question very easily. Notice that there's nothing being added to y or x, quantity squared, and so the center is going to be the origin, 0, 0. Okay, at this point, we do have to figure out, do we have an equation for a horizontal ellipse, and by horizontal I mean wider than it is tall, or do we have a vertical ellipse that is taller than it is wide? All we have to do is look and see where the larger number is under the x or the y. Well, I see that 9 under y squared, that's 3 squared under y squared, that is the larger. Since that's the larger, I know that we have a vertical ellipse. And so vertical ellipse means that it's going to be taller than it is wide. So vertical ellipse. Well then, recognizing the fact that A is equal to 3 and B is equal to 2, honestly, I can go ahead and graph this because I know that the center is 0, 0. If I go up 3 and down 3, that's major vertices. And then B, being the smaller one, goes horizontal since it's under the x, so I go right 2 and left 2 from the center. And the truth is that even if it's going to be a bad ellipse, if I can connect the dots, that's about what we have. Well, recognizing my A and my B get me exactly where I need to get, what are my vertices? Well, my vertices are specifically go from the center and go up 3, so that's going to be 0, 3, and the other one is 0, negative 3. Okay, those are my vertices. The only thing left to find is the foci, but to find the foci, we need to find c. Well, c squared is equal to a squared minus b squared, and so c squared is equal to 3 squared minus 2 squared. So c squared is equal to 9 minus 4. C squared is equal to 5. Take the square root of both sides, and I get that c is equal to root 5. Well, then, where are my foci? My foci are just going to go up from the center a distance of root 5, so this is 0, root 5, and go down from the center a distance of root 5, so that's 0, negative root 5. Alright, let's try another. So for this ellipse, we have x plus 3 quantity squared over 16 plus y minus 1 quantity squared over 25 is equal to 1. At this point, I have almost everything I need. I'm going to go ahead and rewrite my denominators as an integer squared, and so that's going to be x plus 3 quantity squared over 4 squared plus y minus 1 quantity squared over 5 squared is equal to 1. Now we're in our correct format. So at this point, we can find the center. Well, the center is going to be negative 3, 1. And so I'm going to use a different color to mark my center to keep myself on track. Negative 3, 1. There's my center. At this point, if we're going to find the vertices and the foci, honestly, I just need to move in the correct direction. We'll recognize that my larger value is under the y stuff, and so since it's under the y stuff, this is going to be a vertical ellipse. And so vertical ellipse means we're going to go up a distance of a, which is 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I should have marked those in purple, so let's do that now, because these are actually points on my graph. While we're at it, since we are going to have to draw the graph, let's go ahead and go to the minor axis, which is going to be to the right a distance of 4 and to the left a distance of 4. 1, 2, 3, 4. 1, 2, 3, 4. And honestly, for graphing, we're done. We have graphed the ellipse. Alright, so let's write this out. What are my vertices? Well, since 5 is my A, and I move up from the center a distance of 5, I can just write in the vertices that I found. Those are going to be negative 3, 6, and negative 3, negative 5. Well, then where are our foci? To find the foci, we do need to find c, but c squared is equal to a squared minus b squared, and so c squared is going to be equal to 25 minus 16. C squared is equal to 9, so c is equal to 3. And so then, from my center, I can just go up a distance of 3 and down a distance of 3. So 1, 2, 2, 3. 1, 2, 3. And so then I get that my foci are negative 3, 4, and negative 3, negative 3. Found the center, found the vertices, found the foci, and we drew the graph already. Okay, so for this ellipse, let's recognize that this is really x minus 4 quantity squared over 10 squared plus y plus 5 quantity squared over 6 squared is equal to 1. It's already in the nice format. Truth is that at this point, if you want to go ahead and graph it, we can do that very quickly. We know that the center is 4, negative 5, and so 4, negative 5. Then for my vertices, recognize that the value under the x stuff is larger, so that means I'm going to go to the distance 10 to the right and 10 to the left to find my vertices. Well, that's going to be over at 14, and then over here at negative 6. And so specifically now I know that my vertices are at negative 6, negative 5, and at 14, negative 5. We'll find our foci in a minute, but to finish our graph, well, we know that 36 is 6 squared, and so I'm just going to go up 6 and down 6, down there at negative 11. And so technically this is the graph. But now we need to find the foci. And to find the foci is c squared is equal to a squared minus b squared. And so c squared is equal to 100 minus 36. c squared is equal to 64, which means that c is equal to 8. And so then I go from the center, a distance of 8 to the right and 8 to the left, to find my foci. And so my foci are going to be 4 minus 8 is negative 4, negative 5. And then 4 plus 8 is 12, negative 5. Alright, now so for this ellipse, what in the world are we going to do? Well, we're going to have to complete the square first. So, if we want to complete the square, I need to move everything to the right and complete the square. So this is going to be 4x squared plus 24x, leave some space, plus y squared minus 2y, leave some space, is equal to, subtract 21 from both sides, minus 21. There's one more thing we need to do here to make this work out, and so specifically recognize that I have a coefficient on x squared of 4, which means that I'm going to need to factor out that 4. And so what we're going to do is we're going to factor out 4, but that's going to look like this. Plus 24 divided by 4 is 6, and we factor out a 4. Okay. Now this may look a little funny, but this is going to handle everything we need to do. So the first thing that we need to do is we need to add b over 2 squared to both sides. And so for this one it's going to be 6 over 2 squared. For this one it's going to be negative 2 over 2 squared. Got to add both of those to the right, but we're going to have to be real careful about the one that's got the 4 times it. So this is going to be plus 4 times 6 over 2 squared. Why is that? Because of this 4 here factored out, it's got to be multiplied times that 6 over 2 quantity squared. And then on the other side, we just have plus negative 2 over 2 quantity squared. So then what do we have? This is going to give me 4 times x plus 3 quantity squared plus y minus 1 quantity squared is equal to negative 21. 6 over 2 is 3, 3 squared is 9, 9 times 4 is 36. And then negative 2 over 2 is negative 1 quantity squared is plus 1. And so then I get that this is 4 times x plus 3 quantity squared plus y minus 1 quantity squared is equal to 16. So divide everything by 16, and so then we get that x plus 3 quantity squared over 4 plus y minus 1 quantity squared over 16 is equal to 1. And then if you want to be real careful and get this in the correct format that we want, this is then x plus 3 quantity squared over 2 squared plus y minus 1 quantity squared over 4 squared is equal to 1. Alright, so at this point recognize that the bigger number is under the y stuff, which means that we have a vertical ellipse. We also know that our center is at negative 3, 1, and so negative 3, 1. Then, if we want to find the vertices, remember that the vertices are going to be on the vertical axis, and so that's going to be shift up from the center a distance of 4 and down 4. And then, for our minor axis, we go to the right a distance of 2, and to the left a distance of 2. And so I've actually done everything I need to graph the ellipse. But let's write all of this out. My vertices are going to be shift up by 4, so that is negative 3, 5, and shift down from the center but a distance of 4, that's going to be negative 3, negative 3. And then where are our foci? Well, to find our foci, we got to find c, so c squared is equal to a squared minus b squared. So c squared is equal to 16 minus 4. C squared is equal to 12. Take the square root. C is then equal to 2 root 3. And so then where are our foci? Specifically, we're just going to shift up from the center a distance of 2 root 3. And so our foci are going to be at negative 3, 1 plus 2 root 3, and at negative 3, 1 minus 2 root 3. An arch in the shape of an upper half of an ellipse is used to support a bridge that is to span a river 16 meters wide. The center of the arch is 5 meters above the center of the river. Write an equation for an ellipse in which the x-axis coincides with the water level and the y-axis passes through the center of the arch. Alright, so let's kind of superimpose an xy coordinate plane on this. Okay, if we superimpose an xy coordinate plane, then a few things of interest occur. We recognize that our center is 0, 0. Okay. Also, we have a major axis and a minor axis. Well, I actually now know what B is. B is equal to 5, and I know that A is equal to half of 16, or 8. And so this is at the point 8, 5, negative 8. And at this point, we have everything we need to write the equation, because we recognize that we have our major axis is horizontal, and so this is going to be of the form x minus h quantity squared divided by a squared plus y minus k quantity squared divided by b squared is equal to 1. And since I know what the center h and k are and I know what a and b are, I'm done. This is x squared over a is 8, so 8 squared, plus y squared over b squared, where b squared is 5 squared. And if you wanted to simplify it, that is true, that it's x squared over 64 plus y squared over 25 is equal to 1. And so this is the equation of that ellipse. A few other interesting applications of ellipses. Lithotripter, and so it sends sounds to the focus of an ellipse to help pulverize kidney stones. And so you're just sending those vibrations in the elliptical form into the focus. There's also an interesting room in the Capitol building in Washington, D.C., and it's called the Whispering Gallery. And the deal is that because it's elliptical, what happens is the focal points are on different sides, and so the sounds from one end of the room end up on the other focal point and vice versa. And then orbits of planetary objects are elliptical orbits.